All right. So the ones I want to jump to today are the first ones that you see that have my handwriting on it. Which would be like right here. Now, I asked you something last week, and I'll go ahead and ask you today again. It's up to you how you want to do this. I know we had the tornado drill, which really just destroyed one of our days last week to go over this packet. But there also isn't a ton of material on this next quiz. We have a quiz on Thursday. So tomorrow I have the lab blocked off. Like we can go to the lab to work on this week's homework, or we can stay in here working on the packet. Regardless, we're going to be in here Wednesday, and we would have still an extra day to still review for the quiz. But it's just a matter of, do you want one day to continue working on these or two? I'm fine with either one. My first period that had more time, they want to go to the lab tomorrow. Does anybody have a strong opinion one way or the other? You would want to go to the lab. The homework this week's a little bit longer, so that could be. So lab, I still think it's enough. If I didn't think it was enough, I would force you to stay here. I still think between today and Wednesday, there's not a lot of variety on this. So like, it's one of those, either you just get it or you don't. It's not like, oh man, everything is different, I have to go over like all these little wrinkles. It's just kind of either you get it or you don't. So even without that time that we missed, it's still reasonable to think that you should know what you're doing. The homework grades are in already. Everything on the homework you should have been able to understand. I know it's kind of quick and stuff, but everything there was nothing on there that we hadn't gone over. So, what type of a function is this one here on the board? Exponential, sure. So and if you want to be more specific, it's an exponential growth. Let's identify A, C, H, and K. Zeke, what's A here? A, good. Zeke, what's C? No. X, oh dear. Oh no. 1, good. So it's whatever's in front of the X, a low number, which in this case is a 1. What's H? 0, what's K? So which transformation numbers are having an effect on this function? Just A. Yeah, A is the only one that's going to do anything. Okay, and we know, hopefully by now we've memorized the formula. We know that that's going to affect the y's. This being an exponential growth, look, the domain of any exponential function is all real numbers. You can pick whatever x's you want to start with. But what did I recommend to you to use on growths? 0 and positives. So we have a little bit more space here. Not like last week where we were using the table, so I'm going to go back to using coordinate notation. And I'm going to choose to use 0, 1, 2, and 3 to start for the x's. But now I have to figure out which y's correspond to these. So all I'm really doing is taking turns, taking the base, which in this case the base is 5. Zeke, the 5 is not the C, the 5 is the base. I'm going to take 5 to each of these powers. What is 5 to the 0 power? 1. What's 5 to the first power? What's 5 squared? 5 squared is 25, and what's 5 to the third? 125. Now I'm going to get each of these, think of these as starting points before I pop them into the toaster, into the transformation toaster, and then have them pop out already transformed. So go to each one of these, get the x's, and divide by c, which c is 1, I can ignore it. Add h, h is 0, you can ignore it. Anything plus 0 is itself. Then I'm going to get all the y's, I'm going to go times 8, and then plus 0, I can ignore that plus 0 from the k. Yes, Juan? I took 5, so 5 is the base, so I did 5 to the 0 power, 5 to the first power, 5 to the second power, 5 to the third power. And now I go to all of these. The x's stay the same, 1 times 8. X stays the same, 5 times 8. X stays the same, 25 times 8. 3 stays the same, 125 times 8. Just here, look, bonus question. If you were to be asked, what is the transformation, what transformation is this undergoing? What would you say? Vertical stretch of 8. Yeah, that's the only one that's undergoing. So now the toaster pops out a 0.8. It's one of those 4 slice toasters. So it pops out a 140. It pops out a 200, and it pops out a 3 1000. How many points would I like to plot? Well, I'd like to plot 4, but at the very least, I want at least 3. So now there's no right or wrong answer as far as making a choice. You just have to be able to adapt to whatever choice you made. I obviously don't have enough space here. I'm going to have to scale this. The question is, do I want to scale to 1,000 or just to 200? I'm going to just go with the 200. Okay. So I'm going to just ignore this last point here. 3 is enough. What type of asymptote do horizontal What type of functions? What type of asymptotes do exponential functions have? Horizontal, and it's going to be at y equals k. K was 0, so it's going to be at y equals 0. Y equals 0 is right on top of the x-axis. Now we just we're going to count if we're going to scale to 200. Counting by tens would be great, so I'll make that 50. The 10 would be 100. So basically, just adding a 0. This would be 150. This would be 200. So 0.8 would be just below the 10, like it's right underneath the first line. 140 would be where 1 and the 4 is, and then 200 would be up here. And then we just use our sketching skills to come up with the rest. Close enough. You don't have the notes. You know. Caleb, any questions? How's your workout? Good workout, good. Landon, question. I see you thinking. I see the gears moving. Hannah, Banana, Fontana. Anything? Okay. All right, so let's go to this one. Ooh, what's different here? What's different here? I know there's a fraction. Yeah, that's the first thing that catches my attention. But what does that fraction mean? It's not a decay. Huh? Yeah, it does mean a vertical compression. It means we're going to have to multiply by a fraction. But then I also see it's negative. This probably ends up being the most important. Yeah, that there's going to be an x-axis reflection. So when I'm done, this is going to be on the other side of the asymptote. It's still exponential, and it's still an exponential growth. So whoever said decay, how do I know it's still a growth? The base is greater than 1. Somebody said a degree? Oh. Let's see, Zeke, you did here, yeah. Zeke, you do the name the transformation values. What's A? Good. What's C? Good. It's in front of the x to the 1. H? Good. Yeah, so the only thing that's going to have an effect here is the A. And we already said it's going to be a vertical compression and a x-axis reflection, but the formula is going to take care of the points for us. Now, being that you have to multiply by like all the y values by A, sometimes you could be selective as to what points you pick, because you would want to pick points that are divisible by 3. But since my base is also 3, that's going to kind of take care of it for me. I would still use zeros and positives. So 3 to the 0 is 1. 3 to the first is 3. 1, you were asking me, what's 3 squared? And then 3 to the third is 27. Now all I got to do on all of these is get each of the y's. The x's stay the same. I don't have to do anything with the x's. But then all the y's just get multiplied by negative 1/3. 3 times negative 1/3. 9 times negative 1/3. 27 times negative 1/3. So this is 0, negative 1/3, 1, negative 1, 2, negative 3, 3, negative 9. I know we ended up with one fraction, but that's not too bad. That's going to just be right below the 0. Where is my asymptote here? Be specific. ¿Dónde está mi asymptote? At y equals 0, which is right on top of the x-axis. I don't really see a need to scale anything here. I can just leave it counting by ones. The first point would be just below 0. You can start to see the reflection now. Then 1, negative 1, 2, negative 3, and 3, negative 9. Miles, you got that? No notes? Storing it all up in the old toboggan? Good. Anyone? Ooh, fun! So many transformations. Come on, Camila, you can do it. What's A? Good. What's C? Good. What's H? Oh, no! Almost. Yeah, good. H, you got to change the sign. And then what's K? Very good. Is this a growth or a decay? Yeah, and it's a base of 2, so when I choose my parent points, 1, I want to take 2 to these powers. I like to use 0 and positives for growth, so 0, 1, 2, 1. Oops, sorry. I wrote that backwards. Sorry. 1, 2, 2, 4, and 3, 8. Hannah, you keep on giving these looks. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. I'm taking 2 to the... I haven't got there yet. These are starting points. I'm popping these into the toaster. Now let's toast them. Okay? Now the formula is x divided by c plus h, but c is 1. I can ignore c. So all I got to do to all the x's is add h. H is 4. So 0 plus 4. 1 plus 4. 2 plus 4. Now, when I do these on my own, I don't do it this way. But I'm just trying to be demonstrative here. I want to prove a point. So I want to just compartmentalize this and say, hey, look, so I get all the x's and add 4. All the x's I started with, what the toaster did was it added 4 to all the x's. What am I going to do to all the y's? Times 3 and then plus 5. Yep. So I'm going to get the 1 times 3 plus 5. 2 times 3 plus 5. 4 times 3 plus 5. 8 times 3 plus 5. Now I'm going to use my super duper mental math skills to pop out the Pop-Tarts from the toaster. 8, 5, 11, 6, 17, 7, 29. Any questions there? All right. And then now I can decide, okay, how many of those points do I want to include? Do I want to scale? Like yada, yada, yada. Being that I have 20 available to me, I'm just going to use the first three. I won't use that 29 point. I'll just use the first three. Where is my asymptote? At where? Y is equal to 5. Yep, it's always at y equals k. K is 5. So y is equal to el cinco. And then for 8 would be 4, 8. Bam. 5, 11. There. 6, 17 up here. And then I'll just do my best to draw what a growth looks like. Not on these, it doesn't ask me. Okay, here. This goes out to Yash. What's the domain here? All real numbers, negative infinity, positive infinity. What's the range? 5 until positive infinity, yeah, with the parentheses. Is this increasing or decreasing? Increasing everywhere through all real numbers. So, what's the end behavior? As x goes to negative infinity, y goes to 5. As x goes to positive infinity, y also goes to positive infinity. Bam, there you go, Yash. You did it. All right, this one ended up being my favorite problem of the day. I like this one. For the first time today, what type of function is this? What type of function is this? An exponential decay, sure. But we're still going to identify. The only thing that's going to affect is the parent points, the starting points. What's A? Emily, what's A? Good. Emily, what's C? Emily, what's H? Good. What's K? Oh, Emily, no, negative 10. That was close, though. 3 out of 4. Now, because just for the sake of not confusing you, even though I wouldn't do this normally, because I have a better sense of numbers and I can get away with things, but just to keep things uniform, being that this is a decay, what parent points did I suggest for you to use? 0, and I'm going to go ahead and do that. I'm going to stick to the plan, but then I'm going to deviate from that a little bit later. I'm going to show you something else. Okay? So let's go 0 and negatives, because that's what we discussed. If you're confused by that, that's on you, because that's what I had. You know, there's exceptions to every rule, right? But this is what we had discussed before. So 0, negative 1, negative 2, negative 3. Oh, why? You tell me, because this is what we went over. Why negative? Why are negative? The domain is all real numbers. You could pick whatever numbers you want, but why did I recommend to pick negatives here? Because since the base is a fraction, what the negative is going to do is it's going to flip the base. So anything to the 0 power is 1. But then when I take 1/2 to the negative 1, the negative flips the base. So what's the reciprocal of 1/2? 2. And then 2 to the first power is 2. So 1/2 to the negative 1 is the same thing as saying 2 to the positive 1. What is 1/2 to the negative 2? 4. Because you flip the base, and then 2 squared is 4, and then this gives you 8. And once you have that, now everything is the same. I'm still going to apply the same formulas. Okay? So my C is 1 and my H is 0, so my X's are not going to be affected. The X's that I start with are the X's I'm going to end with. But then what's going to happen to all my Y's? Times 20 and then minus 10. So 1 times 20 minus 10. 2 times 20 minus 10. 4 times 20 minus 10. 8 times 20 minus 10. So this gives me 0 and 10. This gives me 30. This is 70. And then this one is 150. And look, if you want to use those and graph, go right ahead. You might have to use a scale because those get kind of big, maybe counting by tens, something like that. Be my guest. That's fine. But let me toss something else out for you. Because that A is such a big number, because you're multiplying by 20, it would actually make sense to try to use a few positives. Look, the whole point of telling you, hey, use 0 and positives, use 0 and negatives, is to help you avoid fractions. You're still going to get an output. It's not like you're getting an error, but I'm trying to help you avoid fractions. But since that 20 is so big, that 20 takes some steps to get rid of fractions for you. So like, watch. Let's say I would have used, and I'll even separate this so you don't get confused later on. Let's use a 1 and a 2. Okay? What's 1/2 to the first power? Oh, no, fraction. No, I didn't want that. You like it. Oh, wait. What's 1/2 to the second power? 1/4. 1/2 to the second power is 1/4. It's not 1/2 times 2. It's 1/2 to the second power. It's 1/4. Well, okay. Well, just like before, the x's stay the same. So 1 comma 2 comma, because there's no transformation to affect the x's. But look at what happens with the 1/2 and the 1/4. You're going times 20 minus 10. 1/4 times 20 minus 10. What's half of 20? 10. 10 minus 10 is, hey, look at that. You know, I went with a positive and I got a number that's more manageable. Doesn't happen always, but with that A being so big. A quarter of 20 is 5. 5 minus 10 is -5. How many points did I come up with to graph in total now? No, how many points do I have? How many points do I have that I can graph? 6. How many would I like to graph? I'd like 4. But if I can get away with 3, that's fine. Now, as long as you manage them correctly, you can pick whichever ones you want. If I don't want to scale, which would be the best ones to pick? The bottom 2 and 0, 10. That's what I did last period. Now, where's my asymptote going to be at? And yeah, regardless of what you pick, whether you scale or not scale, make sure that you have an asymptote at -10. Since I'm not going to scale, I could leave it there. -10. So then I have 0, 10, which would be all the way up here. 1, 0, which would be here. And then 2, -5, which would be there. Now remember, this is a decay. It's going to look a little bit different. So this one would look like that. So tomorrow then we agreed lab. All right, we'll be in the lab tomorrow. Go straight there. Landon. We're going to go straight there. And then Wednesday, we'll go back over this packet for the quiz on Thursday. And then Mr. Smith was nice enough to give you the day off on Friday. You guys don't have to come to school on Friday.